everybody, welcome back to chemistry. And so now what we're going to do is we're going to figure out a way in which you can take the formula for ionic compound and give it its correct name. So let me just give you some quick examples. What you'll have to figure out, for example, is if you see the formula KF, that this is named potassium fluoride. But then sometimes they can get a little bit more complicated. So let me give you one more. So let's say you have Fe3PO42. And so that's a difficult one. And so what you'll have to figure out here is that this is iron, Roman numeral 2, not 3, Roman numeral 2, you'll have to figure that out, phosphate. So I'm going to show you how to do that. And so here we go. So if we can increase the slide. You'll see a bunch of formulas for ionic compounds, and you're going to have to convert them into names. There actually are about 4 types of compounds that you'll have to do this for. And so you sort of have to recognize the type of compound that you have, and then remember the rules to convert that compound formula into a name. Let's look at possibility A. So some ionic formulas, what you'll have is a monatomic cation and a monatomic anion in the formula. So a good example of that is NaCl. So let's talk about why NaCl is sort of a matching of a monatomic cation with a monatomic anion. So here we have Na, and so you might remember Na as an ion is Na plus, and then Cl as an ion is Cl minus. And so both of these are ions because they both have charges, and they're both monatomic ions because you can only see one atom carrying the charge. So how do we provide a name for NaCl? So this is what you do. So to figure out this name, the metal cations in the name will get the same name as the name of the element. The nonmetal anions get the name of the element, but modify with an "ide" ending. So as an example of NaCl, if you're trying to find the name for NaCl, you don't use the words sodium chlorine. Instead, you modify chlorine to chloride. And so the name of this compound is sodium chloride. Okay, so another class of ionic compounds that you might be looking at is a formula where you have a monatomic cation match with a polyatomic anion. So we have an example there with K2SO4. So I'm kind of hoping that you remember that the K there, the potassium, is a monatomic cation. It is K+, while the SO4 there is a polyatomic anion. So it's SO4 and it has a 2- charge. So how do you figure out the name for that compound? So here in the compound name, the metal cations get the same name as the element. The polyatomic anions keep their name in the name of the compound. So you don't change the name of the polyatomic anion at all. And so you figure this out and you will find that K2SO4, when you write out the name for that, is going to be potassium, and then again just write out the name for the polyatomic ion without modifying it, so it's sulfate. So the full name is potassium sulfate. Okay, now another possibility is that you'll have an ionic formula where you're matching a polyatomic cation with a monatomic anion. And so there's an example there. It's NH4S. And so what do you do about that one? So here, when you write out the name of this compound, the name of the polyatomic cation is the same. You don't modify that in any way. And then you add to it the name of the anion. It's going to be the same as the element, but change it to an "ide" ending. And so there, NH42S, you're going to name that as not so much ammonium sulfur, but you have to remember that there, the anion, you have to change the sulfur to an "ide", so it's going to be ammonium sulfide. So in these examples, what we were looking at were monatomic cations, and those monatomic cations were monovalent, meaning that those cations can only have one possible charge. So for example, when we were looking at sodium chloride, sodium, when it's charged, can only be a single positive. It can never be anything else. Now, when you're dealing with cations that are polyvalent, then we have to use slightly different rules. So I need to go over that. Okay, So again, all the examples I went on the previous slide were when the cations were monovalent. Now, when you're dealing with a formula with a polyvalent cation, then it gets a little bit more complicated. And so what you have to be sure to do is when you write out the name of the formula, you indicate what the particular charge of that cation is in the formula by using a Roman numeral. So most of the transition metals are polyvalent and so can have more than one cation charge depending on the anion it's bound to. So for example, iron can have one or two different charge states depending on the anion it's bound to. It could be either be Fe2 plus or Fe3 plus. Copper can either be Cu plus or copper 2 plus, for example. But what you should do for this class is assume that all transition metals are polyvalent with the exception of the four following monovalent metal cations, which are Sc3+, Cd2+, Ag+, and Zinc2+. They can only have those charge states that you see. And again, what you're going to have to do is if your metal in the formula is polyvalent, you're going to have to figure out what the charge of that metal is and then include that in the Roman numeral of the name. So for example, what is the name of FeCl3? So if you were to write iron chloride, you would not get full credit for this answer. And the reason is this. Iron here is not a monovalent cation. It is a polyvalent cation. And you may know that iron can either be +2 or +3. So what you're going to have to figure out is it better to say that this is iron Roman numeral 2 chloride or iron Roman numeral 3 chloride? So how do you figure that out? So the way you do that is as follows. The first step is in that formula you look at the anion, which is chloride. Now chloride is monovalent. It can only have a particular charge, and that particular charge is -1. Now if you look at FeCl3, you will see that there are 3 chloride ions there. So the total charge contributed by chloride ions is -1 per chloride times 3 chloride ions. So it's a total charge contributed by the chloride of -3. So the total charge contributed by the iron should be +3, but there's only one iron atom there. So that one iron ion should have a charge of +3. So you figured out that the iron in FeCl3 is +3. And so the correct name for FeCl3 is iron 3 chloride, which is what I've written down there. Okay, so now what I want to do is go ahead and practice taking ionic compound formulas and writing names for them. And so let's do the first one here. So the first one is KCl. So can we figure out a name for that? So the first thing we want to do is look at the formula and see what kind of ions are there. And so what you can see, or maybe what you can remember, is that K is K plus and Cl is Cl minus. And so both K plus and Cl minus are monatomic ions. So do you remember how to name a compound where the formula has 2 monatomic ions? So the first thing what you do is you write out the name of the metal, because the name of the metal ion is going to be just the same as the metal. And the next thing you want to do is you're going to have to write out the name of the non-metal anion. But remember, in this case, you have to take the elemental name and then change the suffix to "ide." So you could take the elemental name, it would be chlorine, but what you're going to have to do is change "ine" to "ide." So the name of this compound is potassium chloride. Okay, so let's go to the next one. So there we have NiS. And so S, you can look up its position here in the periodic table, and you might remind yourself that when S is charged, it will have a 2- charge. So let me write that here. Now let's talk about nickel. So let's look at the location of nickel. So nickel is here. So one of the things you're going to have to notice is that nickel is a transition metal. And so this block of elements here are the transition metals, and you can sort of see nickel as a part of that. So what you're going to have to assume for this class is that with the exception of 4 metals that I mentioned, anytime you have a transition metal, it's going to be a polyvalent cation. So nickel is got to have some kind of charge, but you don't know what it is. And so when you write out the name, you're going to have to, at the same time, figure out what the appropriate charge of nickel is, and then include that as a Roman numeral in the name. So what I recall is nickel usually is either +2 or +3. So you're pretty much, in this question, you're going to have to figure out whether the name is nickel 2 sulfide or nickel 3 sulfide. So let's see if we can go ahead and figure that out. Okay, so what you can see here in this formula here, NiS, we have one sulfide ion, and the sulfide ion has a 2- charge. So the total charge contributed by a sulfide in this formula is 1 sulfide ion times a 2- charge, and so the total charge contributed by sulfide in this formula is 2-. That means the total charge contributed by nickel needs to balance that. It's got to be 2+. And so there's only one nickel there. So what must be the charge of that one nickel so that it gives you a total charge of 2+? Well, nickel must be 2+. So you just correctly figured out what the charge of the nickel ion is there. So the name of this compound is nickel 2 sulfide. Now let's step back to the first one, which was potassium chloride. So you might ask, well, why don't we have a Roman numeral after potassium? And the reason is, you might remember, when we are dealing with a monovalent metal cation, then we don't need a Roman numeral. So let's confirm that potassium ion is a monovalent metal cation. So potassium is here. And so what you can see is potassium is outside that transition metal block. And so it only is going to have one possible charge, and that one possible charge is going to be a single positive, so it's a monovalent cation. And so when you have a formula with monovalent cations, they don't require a Roman numeral. Okay, so let's go on to number 3, which is Ca3PO42. What is the name of that? So one of the things you'll see here when you look at this is you have calcium, which is a monatomic ion, and then we have phosphate, which is a polyatomic ion. So do you remember how to name that? So what you do is you take the name of the element of the metal, and that will be the same as the name of the ion, so it's calcium. And then the polyatomic ion we just use without changing the name, so it's phosphate. Okay, so for the next one, number 4, we have NH43P. And so it looks to me that we have a polyatomic cation followed by a monatomic anion. So to name that, you write out the name of the polyatomic cation without modifying it in any way. So this is ammonium. And then with the monatomic anion, you're going to have to take the name of the element and modify its suffix with an "ide." So we have a P here, which is here in the periodic table. This is phosphorus. So we have to change phosphorus to phosphide. Okay, so for the next one, number 5, we have copper sulfate. And so here we have a monatomic cation with a polyatomic anion. Now we have to be careful about this. Copper, you might remind yourself, is a transition metal. It is here. And so it is not one of those 4 exceptions. And if so, then it's going to be a polyvalent cation. And so what I recall is copper can be of either one of 2 charge states. It can either be a +1 state or a +2 state. So you pretty much have to figure out whether the name for this compound, is it copper 1 sulfate or is it copper 2 sulfate? So how do you figure out which charge state the copper is in? Again, look at the anion first. So the anion is a polyatomic ion sulfate. It has a -2 charge. There's only one of these anions here. It's not 4. 4 only applies to the oxygen here. So the whole sulfate ion here has a total of -2 charge. And so the copper must balance that -2 charge by having a +2 charge. And so we only have one copper atom there. So what must be the charge of that one copper atom so that its total charge is +2? So to balance that sulfate -2 charge, the copper atom must have a +2 charge. So the name of this should be copper 2 sulfate. Okay, the next one, it is number 6. We have Ag2O. So you have to be careful about this. Let's see where Ag is. So Ag is here. It is a transition metal, but This is one of the 4 exceptions where the metal is not polyvalent. It is monovalent, meaning that silver only has a particular charge, and that charge is going to be positive. So once you identified silver as having one charge that's monovalent, then the name does not need a Roman numeral. So this is going to be silver, and then it won't be oxygen, it'll be oxide. Okay, the next one, PdNO32. What is the name of that? So let's first figure out where palladium is. Palladium is a transition metal. It is not one of the 4 exceptions that is monovalent, and so palladium itself is polyvalent. So you're going to have to figure out the charge of what the palladium ion is in this formula. So we have nitrate here, and so you might recall that nitrate, one ion of nitrate is a single negative charge. Now, in this formula, we have 2 nitrates, and so the total charge contributed by nitrate is 2 minus. Therefore, this whole charge contributed by palladium should be 2 plus. And we're only having 1 palladium ion there. And so that 1 palladium ion must have a charge of +2 to balance the 2 negative charges from the nitrates. So palladium's charge is 2, and that needs to be included in the name. So it's going to be palladium 2 nitrate. Okay, so for the last one, number 8, we have NH4OH. So the key thing here is to identify that we have a cation that is polyatomic. It's ammonium. And we also have an anion, which is polyatomic, which is hydroxide. So if both the cation and the anion are polyatomic names, we write out those names without modification. So the name for this is ammonium hydroxide. Okay, so we move on.